Before continuing with the next examples, it's necessary to add a couple of additional files to the project. The files, QML, PNG, and backend.qml, are available in the Git repository for this course. Start by copying QML.png and backend.qml into the project folder. After the files are in place, open the cmakelists.txt file. Make a small edit to include QML.png in the resources section of the QML module. Next, add backend.qml to the QML files section and set a source file property on it to ensure it's treated as the singleton we will use shortly. Once these changes are made, the project will be ready for the next set of QML Best Practice examples. Use explicit URL resolution. With Qt 6, implicit URL resolution based on the QML file's base URL is no longer supported, making it necessary to explicitly resolve URLs. One way to handle this is by using Qt.resolvedUrl. While the image element in Qt Quick still allows relative strings as sources, this behavior is specific to image and should not be relied upon for other cases. To see this in action, set an image as the background of the application window. In this instance, the image element resolves the relative URL due to its internal handling. However, for other URL properties, this won't work automatically. To demonstrate, add two URL properties. Next, include a component.onCompleted handler. When you run the code, you'll see that another source does not resolve correctly, while resolve source does. Using Qt.resolvedUrl works consistently in both Qt 5 and 6, so adopting this approach even in Qt 5 projects ensures good habits and smooth migration to Qt 6. Delegates should not store state. When using delegates or any other dynamically created objects, it's important to be mindful of their life cycles. Such objects may be destroyed either deliberately or by internal mechanisms, such as when a Qt Quick View decides an object is no longer needed. To illustrate this, create a list view with a button as the delegate. Add a Boolean property called localStateProperty set to false. Then, in the onClicked handler, modify this property. Even without running the code, it's evident that the state change is stored within each button instance. This means each button has its own version of localStateProperty. Accessing these properties from outside the button is risky because the button instances might be destroyed when, for example, they scroll out of view. If a delegate needs to modify an external state, use a more persistent object like the backend singleton added earlier, which has a state property Boolean. However, avoid referencing objects outside the component whenever possible. For model-driven delegates, always prioritize interacting with and updating the model data directly rather than relying on external states. Use group property syntax, including in property changes and states. This tip is more stylistic, but it is recommended by QML tooling for clearer and more maintainable code. Group properties are those where a property is an object containing further properties, often typed anonymously. Let's explore how this syntax makes QML tidier. Start by creating a label with the ID group test label and set its anchors explicitly. This can be made more readable using group property syntax. Similarly, you can apply this to font properties. Let's first set some properties. Then we can rewrite them with group syntax for better readability. This approach also extends to property changes used in states. Set up a state with two property changes, one for color and another for text. Although this works, it requires parsing each property change separately. A more efficient way is to use group syntax within a single property changes block. This method keeps the code cleaner and easier to maintain. Note, however, that this syntax doesn't work for properties of attached objects, as they aren't treated as QML objects. Deprecated injected signal parameters. The automatic injection of signal parameters into handlers is deprecated due to potential conflicts and ambiguities. The QML compiler cannot reliably differentiate between an injected signal parameter and an already declared variable. It also makes it challenging to distinguish between arguments, context properties, and other properties in the component. A common example is the mouse area element. Add a mouse area and write the following signal handler. This code has an unqualified access issue because mouse is not explicitly resolved. If you set the ID of the mouse area to mouse, This can lead to further confusion, as mouse may now refer to the mouse area itself rather than the mouse event parameter. To resolve this, explicitly capture the signal parameter. Alternatively, access the mouse area's own properties directly. Review your QML code and locate all signal handlers where the signal parameter is used, and you can adjust them by either explicitly referencing the emitting object's ID to qualify the property read or using an implicit signal. Removing the signal parameter from the C++ property declaration. Using the arrow function syntax to create an inline signal handler with a clearly defined parameter. Note that no type annotation is needed for this. This approach reduces ambiguity and ensures your signal handlers function correctly. Connections function syntax. The connections element in QML has undergone significant improvements, enabling you to connect to any signal of the same name as the signal you want to handle. This method is more flexible than the older approach as you can replace the target, and it can connect to a signal of the same name. With the new syntax, QML tooling such as QML lint can detect errors at compile time, making it easier to catch mistakes. To illustrate, add a connections element with the target set to the backend singleton created earlier. Define an onUpdated signal handler and include a console.log statement to print out the value. The backend has a value property and an update signal that passes value as a parameter. However, the connections element does not automatically define every signal you might need, requiring a custom approach to match the signal. The new approach involves defining a function with the same name as the signal, such as onUpdated. You pass in value as an integer parameter and print out the updated value. This works because QML allows you to define functions of any name on any element. It's important to note the following. The old syntax still functions but is not recommended. Future updates may render it non-functional. If the target property is not explicitly set, it defaults to the parent of the connections element. While convenient, this can be ambiguous and may cause unexpected behavior if the connections element is moved. If the function name is misspelled or the signal name changes, the function will compile but will not be called. Compile time detection for this issue may be added in future updates. If both the old and new syntax are used simultaneously, only the old syntax takes effect, rendering any newly defined functions inactive. It's best to consistently use the new function syntax. Prefer UI interaction signals over change signals. Instead of focusing solely on syntax, this section emphasizes the importance of how signals are used, especially in controls that allow programmatic visual changes. Many controls have properties that respond to updates, but if their change handlers are also used to write back to the source during user interaction, it can cause binding loops or unnecessary code execution. Controls also offer user interaction signals that trigger only when the user makes changes, not when properties update programmatically. This distinction helps avoid binding loops. For example, add a slider and bind its value to backend.value. This makes the slider reflect the backend's current value. To update the backend when the slider is operated by the user, some might implement two-way binding handlers, but this approach is problematic. The right solution is to separate programmatic updates from user interactions. With the programmatic aspect handled by the binding, focus on user interaction by adding an onMoved signal handler. This ensures the backend value updates only when the slider is physically moved by the user, not when the value changes programmatically. The slider's live property can also be adjusted to further control updates. Another example involves a checkbox. Add a binding for check to backend.enabled and an onCheckChanged signal handler. However, using onCheckChanged with the binding can result in similar loopbacks as with the slider. Instead, switch to the onClicked signal. Using interaction signals like onClicked ensures that updates occur only when the user interacts with the control, avoiding unnecessary loops or conflicts caused by programmatic changes. Always consult the documentation for the controls you use and prioritize interaction signals over property change signals for user-driven events.